after we talk about the future value for multiple cash flows, including the future value for an ordinary annuity, now let's look at the present value of multiple cash flows. The idea is actually pretty consistent with the idea of the future value. So the present value of a multiple cash flow, a series of multiple cash flows, simply will be the present value of every cash flow, and you sum them up. And so if you look at the formula I have here, the first component here, this is the first cash flow you have, and let's say that it occurs m years from today. So you use this payment discount by the interest rate for m years. You notice this formula is actually a little bit different from formula 5-3, which is on page 103 in your textbook, because the one on your textbook is actually wrong. The right version should be what I have here. So according to that idea, if you deposit $100 today and $125 years later and $150 2 years later, now you want to calculate the total present value instead of the total future value. You just need to discount every one and get the total discounted value, or say the total present value. So $100 divided by 1 plus I at the power of 0. It is 0 here because this cash flow occurs today, or times 0. So the present value actually would be the amount itself, $100. Now the first year cash flow, which is 125, will be discounted by 7%, now at power of 1. And the second year cash flow 150 will be discounted by 7%, now at the end of at the power of 2. So total present value 347.84. If we are looking at another example, this is a timeline, and on this timeline you see that the first year you have $100, second year and third year you have $300 each year, and then the fourth year you have a negative 50. So to calculate the total present value, you follow the same idea. You calculate the present value of every one, and you sum them up to get the total 530.08. Now if you are wondering, for example, how do you get this number, because this is from year 2, so this number actually is 300 divided by 1 plus 10% at the power of 2, and this number here will be the negative 50 divided by 1 plus I at the power of 4. So 1, 2, 3, 4, every one discount, and the total present value is the sum of this 4. You can also use a special function in your calculator to get the present value, to get the total present value of this series of uneven, or say unequal cash flows. So in your calculator, if you are using a BA2 plus, this is how you enter these numbers into your calculator. In case you're wondering how to use this function in your calculator, check out the video tutorial in D2L about how to use your financial calculators. So there is a part in that video that I talk about the using the CF, cash flow registry, and NPV function to calculate the total present value of uneven cash flows. So here I'm just gonna tell you the inputs. CFO will be 0, and then the other than that, every year you have a different amount of cash flows. You just need to input them one by one, and then you tell the calculator interest rate is 10%, and then you try to compute for the NPV. Look at the NPV function in your calculator. You can get the total present value of 530.086, which is the same result as you have here when you try to do it manually. So again, refer to the calculator tutorial video on D2L about how to use your calculator with this NPV function. If you have TI-83, it will be a little bit different, but in the video I have for TI-83, you can find the instruction about how to use your calculator to calculate the NPV, you should be able to get the same results. Now let's take a look at how to calculate the present value of this ordinary annuity. Remember, an ordinary annuity is a series of cash flows that have the equal amount, or say same amount over the time, and the first payment starts at the end of the first year. So if we follow the idea of present value of the multiple cash flows, we understand total present value is the total of the individual present values. Now for the annuity, each payment will be the same amount, and then we will simplify this formula just like what we did to simplify the future value formula. Somehow present value formula can also be simplified as the payment amount multiplied by a multiplier, and it is annuity discount multiplier. So this multiplier here, of course, will be a little bit different from the multiplier you see in the future value formula. So we call this the annuity discount factor. So present value of this annuity equals to the payment amount multiplied by this annuity discount factor here. And as you see, this discount factor depends on your interest rate I and the number of years, or say number of payments that you have in this annuity. Now when we use that formula, we can find the present value of a 5-year annuity, so N will be 5, annual payment of 100, so payment will be 100, and interest rate is 8%, so we can plug in all these numbers into the formula and get the present value of this annuity, which is $399.27. I strongly recommend you to follow this formula, plug in the numbers yourself, and check if you can get the same results. If you use a financial calculator, we can just simply input 5 years, 8% interest rate, payment being 100. We compute now for PV. And you notice here we put 0 as FV because we want to tell the calculator that in addition to 5 payment, each payment being 100, there's nothing else. No additional final payment or final cash flow. It does not mean that the future value of this annuity is 0. Remember, we did calculate the future value of this annuity, and it's not 0. So by inputting 0 FV here, you are simply just telling the calculator that there is no other cash flows. That's all. So you compute present value, it turns out to be $399.27. Again, try practice with your calculator and see if you can get the same number. Now we are going to look at the example 5-4 in your book for some practice. So if you have some kind of equipment that would cost $20,000, and they will give you the equipment now if you pay $6,000 per year for the next 4 years. And if you can borrow money at 9% interest rate, the question is, should you pay $20,000 now or accept the 4-year annuity offer of $6,000? So either you pay $20,000 now or you pay $6,000 each every year for 4 years. So the question is, which one is a better deal for you? Which one is a better deal for you? You can think about the second option, where you pay $6,000 each every year for 4 years, and based on the 9% interest rate, you calculate the present value of all your 4 payments, and it turns out to be $19,438.32 based on, or say, following this present value of annuity formula. So that means actually the present value for all your 4-year payment is only $19,438, which is lower than $20,000 cash. So that means you should take the option of paying by the annuity payment instead of paying $20,000 cash now. For a video to explain this problem, you can click on the link here, and I will also provide the link on D2L under web links. If you want to see how to use your calculator, the calculator function to get the results, you can also click on the link that takes you to watch the video about your calculator. Now, I want you to think about 2 practice questions from the end of your chapter 5. First one is, what is the future value of a 900 annuity payment over 5 years if the interest rate is 9%? Second question is, what is the present value for the same annuity? And I would recommend you to stop the video here and do the practice and get your result first, and then check to see if your results are consistent with mine. So for the first question, future value total will be 5,038.6, and for the present value, it turns out to be 3,500. I show you how to use the formula as well as how to use your financial calculator to get the results. Now let's think about annuity deal. We talk about future value and present value of ordinary annuities. What about annuity deal? Recall that annuity deal is an annuity where the first payment occur at the beginning of the first year, and the second payment, of course, at the beginning of the second year. So each payment occurs at the beginning of each period. So the main difference between the annuity deal and the ordinary annuity is that all the cash flows of the annuity deal can get to compound 1 more year than the ordinary annuity. So when that's the case, you get the idea that the future value of an annuity deal will be higher than the future value of a matching ordinary annuity, and the same idea applies to present values. That's why we actually have a formula or equation here that says the future value of an annuity deal is the future value of the matching annuity multiplied by 1 year of compounding. Because remember, we just mentioned it is actually the annuity, ordinary annuity, compounding 1 more year. So that's the equation for the future value of an annuity deal. And similarly, you have the equation for the present value of annuity deal. So that tells you, if you are asked to calculate the future value of an annuity deal, if you have the future value of the matching annuity, simply multiply it by 1 plus I. And if you have the present value of an ordinary annuity, you can also multiply it by 1 plus I to get the present value of the annuity deal. Now, what do I mean by matching? If you have an annuity deal and an ordinary annuity that have same payment amount, same number of years, or say same number of payments, and same interest rate, you can say they are matching. And the only difference is, well, again, the ordinary annuity starts the payment 1 year later, or say at the end of each year, and the annuity deal starts the payment at the beginning of each year. So following that equation, let's see, what would be the future value of a 5-year annuity deal when each payment is 100 and the interest rate is 8%? Since we already calculated before that the future value of the ordinary annuity of $100 payment each year, 8% interest rate, and the future value is $586.66, then we just simply use that number, multiply by 1 plus I, and the future value of this annuity deal will be 633.93. Alternatively, you can use your financial calculator to get the value, the future value or present value of the annuity deal directly. To do that, you need to set the calculator to BGM mode. So to know how to set to switch from the regular, or say N mode, to the BGM mode, you may want to refer to the video posted on D2L. Once you set your calculator to the BGM mode, then you use exactly the same inputs as when you calculate the future value of an ordinary annuity. So remember, the payment equals 200 and will be 3. IY is 8%, and you compute for the future value, and it's 633.93, which is the same amount as you got using the formula here. Now let's take a look at calculating present value of the annuity due. Same idea, that if you are using 8% interest rate, then the present value of the annuity due will be the present value of the matching ordinary annuity multiplied by 1 plus the 8%. So it is 431.21. And if you use your financial calculator under the beginning mode, you compute the present value based on 5 years, 8% interest rate, and $100 payment, and your result will also be 431.21. So by now we have calculated future value of an uneven cash flow stream, present value of the uneven cash flow stream. Remember, just calculate the future value or present value of every one, sum them up. For ordinary annuity, to calculate the future value and present value, we do have the formula for you to follow. You can also use the future value or present value functions in your calculator. And for the annuity due, to calculate the future value or present value, you can use the future value or present value of the matching ordinary annuity and then multiply by 1 plus I, or you'll switch your calculator to the beginning mode and calculate the future value or present value for the annuity due. So then I have several practice questions about annuities, and I'll show you the practice questions, and hopefully you try the practice questions, get the right result, and then we move on to a new topic in chapter 5. So this is the question. This is about annuity calculation to let you understand the power of compounding interest. This is a 20-year-old student who wants to save $3 per day, and then 365 days in a year, so each year she would have $10.95, and she would put this money in a brokerage account, and that account will earn her a return of 12% per year. So remember, she's pretty young, only 20 years old. So the question is, how much money will she have when she gets 65? Between 20 and 65, there are 45 years, and $10.95 each every year. So this is a perfect annuity future value question. And you calculate the future value of this annuity, it turns out to be very close to 1.5 million. So only $3 a day, which is not a very big amount, and you can accumulate about 1.5 million by the time you are ready to retire. And also, you can manipulate the numbers. For example, if she's not 20 now, but already 40, and then how much would she have when she gets 65? You can get the result for the future value. And also, if I change the question a little bit, if she actually wants the same $1.487 million, but she only starts when she's 40, which means she only has 25 years, then how much money does she have to save or deposit every year to match to get to the same goal? So this is a question about solving for payment. And then you notice that we know the future value, that's our goal, and we have 25 years to achieve that. Based on 12% interest rate, each year our payment will be $11,000, a little bit more than $11,000. So $11,000 a year for 25 years can lead you to about 1.487 million future value 25 years later.